So the first thing you notice is that this equation looks a little different because we have a multiple angle. We're dealing with the sine of 3x instead of just the sine of x. So to get a handle on what kind of answers we should be expecting, I'm looking at the graph of this. Naturally, the wavy graph is y equals sine 3x, which remember, the 3x tells me that I hit 3 revolutions on the same original interval 0 to 2 pi. So that 3 is going to have something to do with what happens with our answers here. And naturally, y equals root 3 over 2 is the blue line. And as long as I don't go past 2 pi, you notice that we have 6 solutions. And they all have denominators of 9, which is very intriguing. But remember, whatever we plug in for x, it gets multiplied by 3, and that is the angle that gets us to the root 3 over 2. So there's kind of 2 steps happening in one here. So the question is, as always, how do we solve this analytically? So, coming back to it here. My suggestion would be, and I'm just going to remind us of the interval here. We're saying that x is between 0 and 2 pi. Well, I'm going to call this u because I already know how to handle sine of a single angle. Now, when I do that, though, I have to remember to replace this x by its counterpart in the u world. So if u is equal to 3x, that means x is equal to u over 3. So this means that u over 3 is trapped between 0 and 2 pi, which means u is between 0 and 6 pi. And that 6 pi means 3 revolutions of solutions. So just like we saw with the sine wave, the period was 3 times, or the period was, there were 3 cycles in one period of 0 to 2 pi. So this means we're going to have 3 times as many solutions. So this is going to be fun. So when we find our solutions, we not only have to consider the first revolution, but the next 2 as well. So if sine of u is equal to root 3 over 2, that lands me in the first and second quadrants, and the angle we should be thinking is 60 degrees. So it looks like my angles are, so u is equal to 60 and 120. Now remember, that's my solutions on the first revolution. We want 3 revolutions of solutions. So I'm going to add 360 to each of those angles. Because remember, anything coterminal to those 2 angles will have the same ratio when we take a trig function of it. So add 360, and then that's only 2 revolutions, so now we want the third revolution, add another 360, and that gets us 780 and 840. And that's what u is equal to. Now remember, we want to A, have radian solutions, and B, have x as our variable. So this means that 3x is equal to all of that, which means that x is equal to, and I'm going to divide each angle by 3, and that's going to give me 20, 40, 140, 160, 260, and 280. And then in radian mode, well, multiply each one by pi over 180. That's going to give us pi over 9, 2 pi over 9, 7 pi over 9, 8 pi over 9, 13 pi over 9, and 14 pi over 9. 6 solutions, which is what we saw on the graph earlier. So as you can see, when you have a multiple angle, things get a bit interesting. So just some things to keep in mind. Thanks so much for watching.